And I will discuss about the types of relationship between the variables, and as the latter part of the session I will discuss about the Pearson's correlation coefficient. When we are discussing about the relationship between the variables in the previous session also, we have discussed a method called the Spearman's rank correlation. Under that, we have identified that what is the behavior of the relationship. Therefore, if you consider about the relationship between the variables, basically we can categorize it in three types of relationships that we can see. Number one, or the first one is the positive relationship among the variables. It implies that increasing in x can be associated with increase in y. It is simply suppose that if you are having the variables in this way, suppose that you are having x variable and y variable. As you are having an increasement in x direction, then the variable y will also having an increasement in the y direction as well. Therefore, if you draw a graph for a positive relationship, then you will get a graph in this way. Therefore, you can see that as x increases, the value of y also increased accordingly. Therefore, if you can find out this type of relationship, then we name it as a positive relationship. And if you move for the next one, it is the negative relationship. Yeah, here what we can see is increasing in x tend to be associated with decrease in y. Therefore, here we can see that we are having x and y. Then if you see about the increase of x as you go along with the x-axis, then you may find out decreasement of y. Then you will get a graph in this way. Suppose that if you are started from this point and if you are increasing the value of x, now you can see that in the increasing direction of x, you can see that value of y has now decreased. Therefore, we can see that there is a negative relationship between the x variable and the y variable in this way. And if you cannot find out any effect from x on y or vice versa, then we can say such relationship as the simply we can say that there is no relationship between the variables. Therefore, we can say that the change in x do not seem to have any effect on the variable y. In simply, we can say that even though we are increasing x or decreasing x, then it will not affect on the increasing or decreasing of the y variable. Therefore, if there is no any relationship, then y variable will not be depend on the x variable. The two variables will be behave independently. But in the first two situations, the variables will be depend on each other. That's why we can find out a relationship. But in the third one, it says that no relationship in the sense the variables can behave independently. Therefore, this can be considered as the types of relationship between the variables. But apart from these three relationships, we have identified for positive relationship and the negative relationship. We have find out a scale, whether it is a weak relationship, moderate relationship, or a strong relationship. In the previous session, we have discussed that part as well. Now we will move to discuss on the scatter plot, a graphical way of finding out, or the graphical way to represent the data can be considered as a scatter plot. Therefore, using the scatter plot, we can easily find out whether there is any relationship among the variables. But we have to have a confirmatory analysis for for the information obtained from the scatter plot. Here we can, by seeing the scatter plot, we can suggest that there is a relationship, and we can just say that it is a positive relationship or it is negative relationship or no relationship. But just by seeing this scatter plot, sometimes we may be able to say that there is somewhat a strong or somewhat a weak relationship. But we have to, if we are commenting on that way, we have to have a confirmation on the values as well. If I discuss about the scatter plot, it is a plot of data on a scatter diagram is useful beginning when examines the relationship between two quantitative variables. Therefore, we can say that we can use the scatter plot to have the preliminary analysis or the primary analysis for a data set to identify whether there is a relationship between the variables. Therefore, we can say that the scatter diagram of the observed data can be used to express the relationship between two variables using a particular type of equation as well. I will discuss about obtaining a particular type of equation once we are having a scatter plot or a set of data in a later session. But in this session, I will just discuss about how to identify the relationship among the variables just looking at the scatter plot only. Here, suppose that if you are having two variables x and y, the creation of scatter plot can be discussed in this way. First, what we need to do is we need to mark the x-axis and the y-axis first. Generally, we are taking horizontal axis as the x-axis, and we'll take vertical axis as the y-axis. And you need to use an appropriate scale for x and y-axis. Here we can see the values. It is just the largest value is 11, and smallest value we can see 3. Therefore, I can have it is starting from 0. Then I will have the values as 2, 4, 6, 8, 10, and 12. And for the y direction, I can see that the maximum is 12. Then here also I will take the scale as 2, 4, 6, 8, 10, and 12. As the first thing of creation of a scatter plot, first we need to mark the x-axis and the y-axis, and using an appropriate scale, we have to scale the x-axis as well as we have to scale the y-axis. Now what we can do is we can consider this as a ordered pair, this as a single point. 8 and 12 we can take it as a ordered pair. Then we can mark it in the plot. Here we can see that point is 8, the value of x is 8 and the value of y is 12. Then we can say the first point lies somewhat here. Then the next point, it is 9 and 5. For the value of 9, we can have the value in somewhat here, and 5 would be is quite in this place. Then 10 and 6, here value 10. It is the previous one, 9 with 5. Then we'll have somewhat here. Then 10 with 6, it would be somewhat here. Then 3 with 7, 3 with 7, we can have a plot, or we can plot the point in a place like this. And 11 with 9, 11 with 9, it would be a place we can show it in this direction. Therefore, now we can using this type of plot, we may be able to find out whether there is a relationship. But here we cannot just have a comment on this set of data. It is because still we are having very less amount of data that we have used to create the scatter plot. Here the only thing that I need to explain here is the creation of the scatter plot. Therefore, using this method, we can simply create a scatter plot. Now you can see that several figures have included. Here, these are the figures that we can use to show the positive relationship. Here in the first diagram, we can see that there is a perfect positive correlation among the variables. Suppose that if you are having the x variable and the y variables, whatever variables we are considering as quantitative variables, now you can see that if you see on these points, you can see that all these points are lies on a straight line. Therefore, all the data points are exactly on a straight line. Then we can say such relationship as a perfect relationship. Then you can see that as the value of x increases, we can see that value of y is also increasing. Therefore, that's why we can say that it is a positive relationship. If we see about the next diagram that is which is provided for us, here we can see that it mentioned that there is a high positive relation or high positive correlation among the variables. Here we can see that the points are somewhat scattered. If you draw a line in this way, now you can see that if it is a general line or the most common or most general line that we can have, or most reasonable line which can be created for the points mentioned or points plotted on the graph. Now you can see that some points are somewhat deviated or somewhat scattered away from the line that we have created. But in the first diagram, you can see that all the points are exactly on the on the line. But in the second graph, some points are having somewhat a scatter or somewhat some or small deviation from the line that we have created. But here still we can see that it is a positive relationship. It is because as the x increases, you can see that the value of y also getting increasing, and you can see that it is a positive relationship, and we can say that it is a high or strong relationship just by seeing the points. Since almost all the points are scattered just around or very near closer to the fitted line, you can see that we can comment that there is a high or strong relationship among the variables. But if you see about the third diagram, you can see that if you construct a fitted line for the point, now you can see that still it is a positive relationship. It implies that as the value of x increases, we can say that value of y is also increasing. That's why we can say that it is a positive relationship. You can see that if you move along the x direction, now you can see that value of y is also increasing. That is how we are saying that there is a positive relationship or positive correlation among the variables. And we can comment on the strength of the relationship as well. Here we can say that it is a low positive relationship. It is because you can see that the points are somewhat scattered away from the line as well. That's why we can say that it is a low positive correlation or low relationship. And positive in the sense as x increases, we can see that value of y is also getting increased. And now if you move for the next set of diagrams, you can see that these are the diagrams which I have used to show the negative relationship as well as the no correlation. Here, if you see about the first diagram, you can see that we can see that as the value of x increases, we can see that the value of y is getting decreased. But you can see that all the points are just on the fitted line. That's why we can say that it is a perfect relationship. Perfect relationship, it is because all the points are on the fitted line. But we can say that it is a negative relationship. It is because we can say that as x increases, we can see that value of y is getting decreased. Therefore, if you are moving along the x-axis, you can see that value of y is getting lower. That's why we can say that it is a negative relationship. And if you move for the next diagram, here also we can say that we can fit a general line for this set of data in this way. Here also you can see that as the value of x increases, we can see that value of y is getting decreased. That's why we can say that it is a negative relationship. But we can see that the most points or most of the points are scattered around or very closer to the fitted line. That's why we can say that it is a high relationship or strong relationship, but it is also a negative relationship. But if you move for the third diagram, here you cannot fit that much of a good line. It is because if you are trying to fit a line, then you can see that much more points are deviated from the fitted line. Therefore, in a situation like this, we can say that there is a no correlation. But here we can say that it is quite somewhat an unusual pattern, we can say that. That's why we can say that there is no correlation. But if you are commenting on whether it is a strong relationship, moderate or weak relationship, then it is better to confirm it using an appropriate technique such as using the Pearson's correlation coefficient, since we are using these scatter plots to construct for the quantitative data. Generally, we are using the data which are in the interval scale or the ratio scale to construct the scatter plots. Therefore, scatter plots can be used to just to examine the behavior of the relationship only, but we cannot have the any or we cannot make any confirmatory conclusions based on the scatter plots. Now we will move for the next part. Here I will discuss about the correlation analysis. Correlation analysis measures the strength of the relationship between the two variables. When we are discussing about the association or the relationship among the two variables, first test that we have discussed was the chi-square test. Under the chi-square test, we have just found out whether there is a relationship among the variables or there is no relationship among the variables. At that point, we did not able to find out how much or what is the strength of the relationship. We did not try to find out the strength of the relationship among the variables. But once we move for the second method in the previous session, then at that point we have discussed just about the strength of the relationship as well, but it was somewhat a less powerful test compared to the technique that we are going to discuss now. It is because we have not used the exact value. Apart from using the exact value, what we have done was we have ranked the data and we have used the ranks to obtain the relationship among the variables. Therefore, in the Spearman's rank correlation also, we did not have that much of powerful test. It is because we just use the ranks to find out the relationship among the variables. But now what we are going to do is, under the correlation analysis, we are going to find out or measure the strength of the relationship among the variables. Here, when we are going to consider about the correlation or the relationship among the variables, there would be several types of relationships we can find out. We can find out a linear relationship, we can find out quadratic relationships, we can find out cubic or biquadratic or any higher order relationships can be find out. But in this session, we will just limit it to the linear relationships only. Therefore, here we are just using the finding out the linear relationship among the variables only. Linear correlation is a measure of the degree to which two ratio or interval scale variables are associated. Here what it says that using the linear correlation or the using a linear relationship, we are going to find out a linear association among the variables which are in the ratio scale or interval scales. And when we are going for the correlation analysis, we can use the statistic called the coefficient of correlation, or simply we are saying that correlation coefficient for as a measure of the correlation. If you move for the or if you discuss about the correlation coefficient or the coefficient of correlation, we can see that the coefficient of correlation always lies in between -1 and +1. In the previous session also, I have mentioned about the set of values based on this -1 and +1, and the values that among these -1 and +1, we have find out a region for finding out the strength of the relationship as well. Therefore, if I just have a quick look towards that as well, here what we had was we had the scale from -1 to +1, then we had the value 0. If we are having -1, then we comment on that that as there is a perfect negative relationship among the variables. If it is 0, then there is no relationship among the variables. If it is +1, we comment that there is a perfect positive relationship among the variables. But apart from these three values, we have find out some other regions using the 0.3 and 0.6 in the positive direction, as well as -0.3 and -0.6 in the negative direction. Therefore, using these set of values, we have identified that here we are having 0 to 0.3. It is a weak relationship for the both sides. But if it is in the what we are saying as from 0.3 to 0.6, then we are having a moderate relationship. It is same for the minus region from minus 0.3 to minus 0.6. And if you are having a value for the correlation coefficient, a value from 0.6 to 1, then we can say that it is a strong relationship, and it is same for the negative direction as well. And apart from this, based on the sign that we are having 0 to 1 and 0 to minus 1, we have them as, we have marked them as the positive and negative respectively. Therefore, this is the scale that we have discussed previously as well. Therefore, it can be also applied for the correlation analysis as well. Here for the finding out the coefficient of correlation, generally we are using the summary measure as the Pearson's correlation coefficient. Now we will discuss about the Pearson's correlation coefficient and how we can use it for calculations and how to find out the relationship among the variables using the Pearson's correlation coefficient. Pearson's correlation coefficient measures the strength of a relationship between the two variables. To compute the Pearson's correlation coefficient, we can use the equation mentioned here, where R equals summation of xy minus n x bar y bar over square root of summation of x squared minus n x bar squared times summation of y squared minus n y bar squared, where we are having the notations as x bar as the sample mean of x and y bar stands for the sample mean of y, and n is supposed to be the sample size that we are considered in the data set. Therefore, using the Pearson's correlation coefficient or using this equation, we can calculate the Pearson's correlation coefficient for a set of variables, and then you must get a value in between minus 1 and plus 1, and according to the value we are getting, we can use this scale to comment on the value that we are getting. But apart from finding out the Pearson's correlation coefficient, previously also I mentioned that here we are only finding out the linear relationships among the variables only. Therefore, prior to finding out the Pearson's correlation coefficient, we must have a quick look about whether the data follows a linear behavior. If the data does not follow a linear behavior, then we have to go for an alternative method, or if we need to make the transformation to make them into a linear form. Therefore, as an example, here we have considered that 9 students held their breath once after breathing normally and relaxing for 1 minute, and once after hyperventilating for 1 minute. Therefore, the values for these 9 students, here the 9 students are, we are considering the same students under the normal condition as well as under the hyperventilated condition. And this would be the set of values that we are getting for the student number 2 under the normal condition and the hyperventilated conditions. And this would be the values that we are obtained for the student number 9 under the normal condition and under the hyperventilated condition. And as the first thing of finding, or as the first thing for the correlation analysis, I mentioned that we need to find out whether there is a linear relationship among the variables or not. Now we can use a scatter plot to find out whether there is a linear relationship among the variables. Now I have created the scatter plot for the normal and the hyperventilated data provided for us. Now we can see that the created scatter plot, it is quite in this way. If I just take the random points, here we can see that the point is 56 under the normal. The value for value we have obtained as 87 under the hyperventilated. Therefore, now we can see that under 56 and 87 would be this point. Then the next point would be 56 and 91. Now we can see that that point is mentioned here. Then we can see that all the points are marked, or here we can see that there are altogether 9 points, and all the 9 points are marked on the scatter diagram. Now what we need to do is we need to find out whether there is a linear relationship among the variables. If we can find out a linear relationship, then we can move further for calculation of the Pearson's correlation coefficient. Here we can see that if you are trying to fit a line for or generalized line for this set of data, we may able to create a line in this form, but it does not need to fit, or it does not need to be placed each and every point exactly on the line. Here what we are going to do is we are obtaining a fitted line, therefore the generalized line would be the most appropriate technique of finding out the relationship. Here as soon as you see this set of data, we can see that there is somewhat a linear behavior of the data. Here I can say it is quite like this way. Now we can say that this is the fitted line or generalized fitted line for the set of data, and we can say that there is a linear behavior in the data as well. But as soon as you see this scatter diagram, we can say that there is a positive relationship among the variables then under the normal condition and the hyperventilated condition. But still we cannot say that how or what is the exact strength of the relationship. But as soon as you see this graph, we can comment that there is somewhat a strong relationship. But anyhow, we need to have a confirmation on that as well. But it is no need to have another confirmation for the positive direction. Here we can see that there is a clear way. As x increases, we can see that there is a clear way of increasement of y. That's why we can see that there is a positive relationship among the variables. Now what we need to do is, since we have identified that there is a linear relationship among the variables, now we can move for the further analysis. Here we are going to find out the Pearson's correlation coefficient for the Freuded data. Using this equation, if you are going to find out the Pearson's correlation coefficient, we may need some values such as summation of xy, summation of x squared, summation of y squared, x bar and y bar. Those are the values which will be helpful for our calculation. And now I will explain how we can use this type of or this set of data for the calculation of the Pearson's correlation coefficient. As the first thing, what I am going to do is I am marking the here. I would like to mention this as well. For finding out the correlations, we can, or finding out the relationships, you can select one of these variables as the x variable, and the remaining variable would be the y variables. If you are changing the variable, it will not be affected on the final outcome. Therefore, you can select, you can arbitrarily select one variable as the x variable, and the remaining variable would be considered as the y variable for the analysis. In this set of data, I will consider my x variable as the normal condition, and I'm taking y variable as the hyperventilated condition. Therefore, as the first thing, and for the easiness of the calculation, I will write down these set of values in the vertical manner. Here the row wise we can see the variables, but I will try to write it in the column wise manner. Therefore, as the first thing, I will write it in the column wise manner. Now if I am writing the variables under the in here, we are having the normal condition. I am taking the normal condition as my x variable, and I have to take the hyperventilated condition. I'm taking this as my y variable. And if I write down the values for the normal, we can see the first value is 56, next value is again 56, then 65, again value is 65, then next value is 50, then you can see the value is 25, then 87, 44, and 30. Now we can see all the 9 values have mentioned, and you cannot change the places. You have to place the value as it is. It is because this would be an ordered pair. Therefore, for the next part, the hyperventilated data is selected. For this part, we'll start from the first value, it is 87. Then the next value is 91. Thereafter, 85. Then 91, 75, 28, 122, 66, and 50. Now, these are the data provided under the normal condition and the hyperventilated condition. And if we see about the equation for calculation of the Pearson's correlation coefficient, it is given as R equals summation of xy minus n times x bar times y bar divided by square root of summation of x squared minus n times x bar squared here we can see summation of x squared minus n times x bar squared and then summation of y squared minus n y bar squared. Therefore, this is the equation we are using. Then we need to find out the values for summation of xy is needed. Then summation of x squared is needed. Summation of y squared is needed. Then we need the value for x, we need the value for n, we need the value for x bar, and we need the value for y bar. We need all these values to have an answer for this question. Therefore, as the first thing, I will create these columns. To obtain the summation of x squared, we need the values for x squared. We need the next column can be created as x squared. And then thereafter, I will create column for y squared, and next column I'm taking as xy. Therefore, these are the columns that we need to create, and at the end of these each column, I will create the summation. Here, if I am taking the x values, I am getting the summation of x. For this column, you can see that it is for the variable y. Here I am getting the summation of y. Then in the next column, it is the x squared values. If I get the summation, I am getting summation of x squared. Here, y squared values were obtained, and if I get the summation, I am getting it as summation of y squared, and for the last column, I am getting the summation of xy. Now we'll see how we can get these summations. Prior to getting the summations, I'll try to fill these three columns. Therefore, here as the first column, it is summation, it is the x squared column. Then for the first value, what we can take is 56 squared. We can get that value as 3136. For the second value, again 56 squared is needed to use. Then 3136. In this way, we can fill up this column. Therefore, the values would be this way. We can find out the values. Square term of 50, we'll get 2500. Then next value is 625. Then 7569. Square term of 44, it is 1936, and square term of 35, it is 1225. Then we need to get the square term of the y variable as well. Then y squared, it is 87 squared. We can get it as 7569. Then square term of 91. Here we'll get 8,281. Then similar manner we'll get the values 784 as the square term of 28. Then square term of 122 we'll get the value as 14,884. Then square term of 66 we are getting 4,356. Then the square term of 58 we'll get it as 3,364. Then the next column, to obtain the next column, what we can do is we can take the multiplication of the x and y column. As the first value, what we can get is we can get the multiplication of 56 and 87. 56 multiplied with 87, we are getting the value as 4,872. Then the next value can be obtained as 56 into 91. Then we'll get it as 5,096. Then similar manner, we'll get the values 5,525. As the last value, it is 35 into 58. We'll get the value as 2030. And now what we need to do is we need to get the summation of each column. It is because all of these values are used in the equation. Then if I get the summations, we can see the summations in this way. Summation of x would be equal to 483. If you total the value in the first column, we'll get this value. Then the summation of y, we'll get it as 703. Then summation of x squared, we need to get the total of the third column. Then it is 28,577. As the summation of y squared, we'll get the value as 60,369, and summation of xy will get the value as 41,406. Therefore, these are the values that we are getting as the values for the summation, and we need one more value. If we see about the values that we have obtained, summation of xy, it is 41,406. Summation of x squared, we got it as 28,577. Summation of y squared, 60,369. Then value of n is need to be find out. Value of n we can consider by considering one column. We can see how many values are there, but anyhow we need to, if you need, we can have it is the number of ordered pairs that we can see in the data set. Therefore, anyhow we can see that we have selected 9 students for the experiment. Therefore, value of n would be equal to 9. Then value of x bar has to be calculated. In the previous sessions, we have discussed about obtaining the mean value. X bar can be obtained by summation of x divided by n, where we can get this value as 483 divided by 9. Here, without converting this into decimals, I will use this as a fraction. 483 divided by 9 would be the value of x bar. It is because it would be much more easier for the calculation. Otherwise, if you are rounding off at this point, then we will be again at the trouble in the final answer. It is because if you are rounding off at this point, then the final answer would be much more deviated from the original value. Then to avoid such errors, then we can consider it as a fraction. Then y bar can be obtained as using the equation. Y bar can be taken as summation of y over n. Then we'll get it as 703 over 9. Therefore, we'll get the value of y bar in this way. Now, what we need to do is we need to have the substitution now. Then substitute it here. Then we'll get the value of r equals summation of xy. Summation of xy was obtained as 41,406 minus value of n is 9. Value of x bar, we can write it as 483 over 9. Value of y bar can be considered as 703 over 9. And thereafter, we need to do the substitution. It is the denominator, we are having a square root. And if you are writing down the values accordingly, summation of x squared, we can have the value as 28,577 minus n x bar squared, value of n is 9, then x bar squared, value of x bar is 483 over 9, and its square term has to be considered, and it is inside only quantity inside the first bracket. Then inside the second bracket, it is we can get the value for summation of y squared. It is 60,369, then minus ny bar squared, value of n is 9. Then y bar can be taken as, here it is taken as 703 over 9, and then we have to consider its square term, since we can see that there is a square term in the equation as well. Therefore, once you perform this calculation, then you will end up with the calculation as 0.9662, accurate to 4 decimal places. Therefore, now this is the value you are getting, and if you need, you can just round off it to 2 decimal places, but it is not compulsory. But at least 4 decimal places, if you are finding out the values, it would be much more good. It is because you can just have much more accurate answer for the relationship among the variables as well. Now what we need to do is we need to comment on the answer that we have obtained. Now according to the scale that we have discussed previously as well, now we can see that the calculated value for our question, it is somewhat here. Values of we can get, it is 0.97. Therefore, in this region, we can say that it is a strong relationship, and then it is having a positive value. Therefore, we can say that there is a positive, or there is a strong positive relationship among the variables. Therefore, we can comment on the final answer as well. Therefore, we can say that there is a positive, strong, or other way around, it would be much more appropriate. There is a strong positive relationship among the variables. Therefore, this is how we are commenting on the answer that we are getting under the Pearson's correlation coefficient. Therefore, anyhow, again, I would like to highlight this as well. When you are obtaining an answer, it should be exactly in between -1 and +1. You cannot get any values apart from those, beyond those the region mentioned. The value that you are obtaining should be exactly lies in between -1 and +1. And this is all what I need to discuss for this session, and thank you all.